How are we feeling now about the initiation of muscle contraction? Yeah? Easy? All right, let's do it. Brain sends a signal down the alpha motor neuron to the, what gets released? Into the acetylcholine binds to the sending and down the to the, okay, that releases into the, calcium binds to troponin, pulls myosin, the binding site, actin and myosin cross bridge. Remember how hard that seemed a month ago? So easy now. At rest, myosin head is at, with what on it? Okay, so once the cross bridge happens, what happens? Phosphate is released, triggering power stroke, which means center of sarcomere, 45 degrees, pulling the actin. Then what happens? Causing trigger state, so we're stuck at 45 degrees. How do we get out of that? Binds to the myosin head, causing release. Then what do? Break down the ATP, releasing energy back up to 90 degrees. Well done. Well done. I'm proud of you. Okay, how about force and speed characteristics? Can someone name and explain a speed characteristic? Go ahead.
More dense sarcoplasmic reticulum,
Okay.
shorter distance for calcium to travel to bind with photos.
Okay, therefore, so we open the binding site faster, right? Calcium gets there, open the binding site, so we go through muscle contraction faster, and your explanation should end with, and therefore we achieve peak force faster. Okay, how about a force characteristic? Go ahead.
Larger motor unit.
Okay,
There's a larger motor unit, meaning the neuron innervates more muscle, therefore it will cause a lot more, a bigger contraction, therefore creating a stronger peak force.
okay, so we have more power strokes because we have access to more fibers. Power strokes, higher force. Good. Very good. All right, then we went into chapter 3, which was initiation and propagation of the action potential. How do we feel about that one? Okay, what's on the inside? What's on the outside? The membrane is polarized and the resting membrane potential is, okay. Brain sends graded potentials which accumulate through the process of summation. How strong does the signal need to get to? It needs to be a 15 millivolt signal that gets us to negative 55 millivolts as the membrane potential, which is now depolarization. What does that cause? Sodium enters, creating action potential, which travels through saltatory conduction. It arrives at the, causes the release of, into the neuromuscular junction, binds to the, creates a muscle contraction. What's happening back at the neuron? Open, potassium exits. Membrane is hyperpolarized. How do we fix that? Moves the sodium, potassium, and the membrane is, I'm like a proud mom right now. So happy. Okay, let's, excitatory signal causes depolarization, which causes contraction. Inhibitory signal causes hyperpolarization, which causes relaxation. Does anyone want to explain sensory motor integration?
No.
Sensory motor integration is the integration between the sensory system and the motor system. It starts with a stimulus, sends in an afferent signal to the integration center, which sends out a response. Efferent response. Okay. If the response cancels the stimulus, if the response enhances the stimulus. Okay. Give me an example of a reflex that is positive feedback. Autogenic inhibition with a stretch stimulus, okay, because we started with a stretch and we responded with relaxation. So that enhances the stretch positive feedback. Good. Give me another example of a reflex that is positive feedback. Okay, so we start with contraction of the agonist. We respond with relaxation of the antagonist. That enhances the stimulus positive feedback. Very good. You guys were quick on that. Length tension relationship.
Medium is peak.
We want to live.
What does this mean?
At the bottom of a bicycle, and at the top of a bicycle, you're not as strong.
Okay, because when the muscle is long, why is force production low?
We can't cross bridges.
There's not as much overlap between the actin and myosin, so fewer cross bridges, fewer power strokes. When the muscle is short, why is force production low?
We can't power stroke and
Okay, so the problem is not cross bridges there, right? When the muscle is short, remember the drawing of our fully contracted sarcomere on the first day? That looked like this. This is when the muscle is short. We can cross bridge as much as we want, but we can't power stroke, so we can't produce force. Okay, yes?
You mentioned this briefly, class. We had two main ways that a muscle would stop. And so that would be, we stop the signal, so that, and then we fully contract.
Yeah, so if the Z disc is hitting the myosin, we can't shorten anymore. Yeah, and if we stop sending a signal, calcium gets pumped back into the SR, binding site gets covered, muscle contraction stops. Yep, awesome. And that brought us into chapter 2, which we just finished. Sounds like you guys are doing really well. Do you feel pretty good about it? I know you have a big drawing to practice, but you still got some time. All right, I will hang out here if anybody